All right, let's get started. Let's see. I mean, I've been going through all these problems, and I'm trying to figure out which would be a good problem to solve. I feel like this one is interesting, the copy list with random pointer. So I'll look into this one, and that's what we'll solve. Alright, I'm going to put this aside. Then, let me see if I can get this iPad to work. Too much. There you go. Alright, so we want to copy a list with a random pointer. A linked list is given such that each node contains an additional random pointer, which could point to any node into a list or not. Return a deep copy of the list. Okay, so what I will use to solve this question today is going to be, I usually tend to use Python for all my coding interviews. It's my strongest language, and I feel like the standard libraries and some of the things that Python offers just off the bat makes it easier in a high pressure situation like an interview to use that over some of the other object-oriented languages that I know, like Java. So yeah, I'll use Python. So I think usually what I do is whenever there are questions like linked list or trees or anything that has to do with an object representation, what I'll do is I will quickly write an implementation. So it shouldn't be def, it should be class. So I'll write a quick implementation of the class, just so I can refer to it throughout the question. So I'll say def init, and then of course this will take in self, and then for now I'll just leave it blank because I don't know what this could be. Okay, so I know it's gonna have a value, so self.val equals to val. And then I know it's going to have a next, which is essentially going to be a node. Next. And random. So that's how this is different from the other typical linked lists that we see. So I'm going to pass in val, say, 0 is going to be my default value, and then for next my default value is just going to be none, and then for random I'll also put it as none. The reason this is nice is because it kind of allows me to implement this class without worrying about, oh, my class doesn't accept random or next as a parameter. So I don't know if I'll need this, but at least this is like a defensive way of making sure that even if I don't pass in those parameters, they will have some default value that I could rely on. Okay. Let's see here. So what do they want? They basically want me to create a linked list that preserves all the next and random pointers. So if I want to make a deep copy of the linked list, that should be easy, right? I basically keep a variable. So I assume this function. Okay, so I think the right question to ask at this point is, okay, so I mean they've given us the class implementation, so I guess I didn't need to do that. Should have checked this part first, but I think it's not safe to assume that your interviewer will, especially at places like Google. I've usually seen they don't give you anything. They'll just tell you the problem statement, and they kind of expect you to ask them like, okay, so I'm just going to implement you know, the node class, and you can tell me if this looks reasonable. In Leetcode, it's a lot of the stuff is already given, so I think this is my bad. I should have checked this first. So the other thing is you make sure that you ask them, okay, so what function am I implementing and what the feature should be. So it looks like it's pretty obvious from the Leetcode here. What we need to implement is essentially this function called copy random. I'm gonna snake case this because that's how Python is. Also, this is Python 3. I mean, I guess I'm using Python 3, it doesn't matter. So it takes in self and head. I mean, because of the nature of Leetcode, these things are like class methods. I'll just keep it simple because in a programming interview, nobody's really expecting you to consider self and all that shit. So I will just make it a regular function. Okay, so let's go back to that. Okay, so basically I'll get a head, which essentially is going to be a variable that contains the head linked list node. So what I'll do is I will make, what I kind of want to do is, so if I'm going to sketch this thing out, so if this is what my linked list looks like, so we're kind of following their one, and then this random points to this, but this random points to itself. What I want to do, and so in the context of this problem, the variable head contains this node right here. So what I want to do is, because I have to return a deep copy, I'm gonna make another variable and I'm gonna call it something like copy head, and then I can sort of basically do an O of n traversal where I go one by one on the next elements of this linked list, and I basically just build copy head according to that. So I'm gonna copy this here, and then I'm gonna copy this here, and then this is just gonna be none. So now I have a deep copy of the linked list, but I think the problem is the random. So I think the way I'm thinking, what we need to figure out is a way to understand a mapping of the old copies of the object to this copy. Because right now I'm thinking, if I hold on, let me think about it. Because I can create next at a time, but I cannot create the random, because random could be pointing at something else completely down the line. So say this is a very large linked list, so this random could potentially be pointing over here, and then what will happen is, if I create the random, because it doesn't exist, if I create this random now, then when I get to next later, I won't have a way to know, hey, have I created this node before because of a random pointer, or am I creating it for the first time because of a next pointer from my previous node? Does that make sense? So in order to prevent that, we need a way to figure out, because we don't want to create these nodes twice. So if I create, one way to think about it is, if I've created it because of a random number because of a random pointer before, I don't want to create it again. So I think what I can do is I can create a copy of the linked list with the next pointers intact. That allows me to create all the nodes just the once. And then what I can do is, as I'm going through them, I can sort of create a dictionary where the old head points to the new head of the object that's created. So what I want to do is, in this Python dictionary, I want to hash the old head. So that's going to be my key. Why is this doing this? Okay, so this is going to be my key, the old head, and then my value could be the new head. And then what happens is, I can create this linked list in O of n transaction, O of n runtime. But then what I can do is, I can simply go through this old old linked list again, and at every step I can just check, hey, what is the object that this random pointer maps to? Look up that object in this list. So if I do D of old random, I'll essentially get a new node, right? Something from here, any of these. And then I'm just going to say and I'm going to kind of traverse these in parallel. And I'm going to say, okay, so then so I'm going to say if this is my copy head, so I'm going to say something like copy head dot random equals to D of old head dot random. Does that make sense? Well, I hope it does. Alright, I'm just going to start implementing it, and hopefully it'll make more sense. I'll wipe this stuff out. Okay. So first thing, like I said, I want to do is make deep copy of next pointers. Okay, so I know my current head is head, so okay, so let's just store a variable, and I'll tell you why this is good. I'll create a new variable and point it at head as well, that head node, and then I'll have something called new head, and this is just gonna point to none for now. Okay, and then the way I want to do this thing is, of course, we will need a prev pointer because I'll need to point the last object I created, so the previous object. I'll need to say something like prev.next equals to the current object. Excuse me. Alright, so let's do while. Okay, you know what? I'm just gonna get rid of this because this is not really helping us at the moment. Oh, where did it go? Okay, whatever. I don't need to know this. Yeah, there you go. Okay, so while why is this like this? Can I change the paper? Okay, I can change the paper width. I'm gonna say while head. So I know my new head needs to be a copy of this thing. Okay, so I know if not. Okay, let me not do that first. Okay, so I'm gonna create the new node at this stage. So I'm gonna say n equals to a node, and this takes in head.val, head.next, and then I don't need to pass in the random, so random is just none for now. And then I can say if previous, so was there a previous node? Then prev.next you know what, yeah, I don't want to make it, I just want val. Yeah. If previous, then prev.next equals to n, so this new node that I've made. So in the first pass, this is not going to happen. And then I can say if not new head. So the new head is basically the deep copy linked list that I'm creating. So new head is what I'm going to be returning at the end, right? Because that's the basically starting point of the new deep copy of the list. So I can say if not new head, then new head equals to n. So I know this is weird, but if you think about it, this if block right here, this will only execute once. So only the first time that we are going through this, because in the next loop, because at the end of the day I'm going to do a head equals to head.next. In the next loop, new head, if not new head, this logic will never be true, because new head won't have none in it. It'll have something in it, so it'll always be true going forward. So it's only false once in the first iteration. And then I can say, I think after that I can just say head equals to head.next. Right? So the reason I made this old head here is because I'm moving this pointer of head forward. Now if I needed to ever reset this to the correct head position, I can always just refer to old head, that variable. So I don't know if this is the best way to do it, but yeah, I mean, whenever I've come across linked list type questions and I have to do some sort of iteration, but I still need to keep track of what the head was, this is usually how I do it. Okay. So what else? Okay, so while head n equals to now node, and this reads like need.valid. So we're doing well on time. We're 15 minutes in. And then if prev.next equals to n, if not new head equals to n, and head equals to head.next. So at some point this is just going to be none, and then we'll have our new linked list. I'm gonna remove these. Okay, so this has just made the deep copy of next. Oh, we forgot to do one thing. Before head equals to head.next, I talked about how we wanted to keep that dictionary. Oh, there's a little gap here, so let's just call this random dict. And in this dictionary, I want to keep track of the old, well, actually, this isn't even a random dict, right? This is more of a old head to new head dictionary. So I think let's just name this something a little more appropriate. Let's just call it old to new, OTN dict. Okay, so now I can say OTN dict head, because that's my old head, right? Well, that's my old node, equals to n, right? Because n is my new node, and objects are hashable in Python, so that should be fine. Okay, now I can say head equals to head.next. And we're doing this because this is going to be helpful when we do the random ones. It'll help us keep track of if we've already created something, I think. So let's do that now. So we've made the deep copy of next. Now we want to do deep copy of random, and we are doing that without creating new objects. We're going to be reusing the objects that we've made before. So again, we're going to start from, so I can just say head equals to old head, right? Because old head is still pointing to the original place. And then new head equals to new head equals to not, well, new head now points at the new head that I want to return, but I also need to iterate it. And I feel like what can I call that? Maybe something like iterator head. So it head equals to new head. the reason I'm doing this again is so that I don't mess with the actual pointers that I need to return later. I guess it's okay to mess with the old head now, but you know, I guess it's just best practice to not mess with it. Okay, so let's do while head, and we know that head and iterator heads are going to be the same size, so we don't really need to worry about that part. So while head actually, let's iterate over the new head because that's what's necessary. Wait, how would I iterate over? Because it's not like an array. It's not like I can iterate over both of them at the same time. Oh wait, no, I can. Yeah, it doesn't matter how I think about it. They all, yeah. It doesn't matter which one I take to iterate over. So if I do while head, then the random iterator head, that's my new list, random, this should be equal to OTN dict head dot random. So that way, basically I'm just doing a lookup on that dictionary that I made before, and then I'm reusing that. And now I can just iterate forward, right? I can just say head equals to head dot next, and then iterator head equals to iterator head dot next. I think we're done. Now I can just return new head. Okay, so I think the best way to be confident in this solution is to just test it real quick on a very small input. So we'll take the input that they described. So which is something like 1 and then 2 and then null, and then this points here, but this points here. So this one is the next pointer, the upper one is the next pointer, and then the bottom one is random pointer. So I have this variable called head, it points here. I create a new node with head.val, so I create a new node with head.val, and I have another pointer called prev that points at nothing right now, it's pointing at null. Oh, that's another thing that I didn't do. Yeah, see, this is why it's important to go through test cases. So prev should be n as well, and we'll see why in a second. And then if not new head, that is true, so new head equals to n. So I'm just gonna roughly draw here, new head points at this guy now, and then OTN dict head equals to n. So there's a mapping from this to this now, and then prev now equals to n. So if you see here, prev instead of there now points at this guy. Well, not this guy. So that's h, not n. So prev now looks at this guy. That's the new node. And then I say head equals to head.next. So this now looks at this. And then if prev, that is true this time, prev.next equals to n. What is n? I create another node with the value 2, and then I'm saying prev, which points at 1.next equals to 2. And then if not newed head, that code doesn't execute anymore. OTN dict head equals to n, so there's a mapping here. Oh, that's not what I meant to do. That's what I meant to do. And then prev equals to n now. So instead of looking at here, this is now looking here. And head is head.next. So just looks at null, and then it doesn't execute. So we know that by default everything's next points to null because of this logic right here. So at least our list mimics it in terms of the next things. Okay, so now let's scroll down and let's look at this logic and see if that helped us. So now we point head to old head again, so we know old head was pointing over here, so head is pointing here again, and now we have a new thing called IT head. So I'm just gonna call this IT head, and then it points at 1. So while head, IT head.random, so this random is equal to what? OTN dict head.random. So what is the value of 1 dot, so this guy's random? The value of this guy's random is this node right here. So what is the mapping between this two? So in the dictionary, what value does it hold? This node right here. So the random points here. And then I say head equals to head.next, and then I say IT equals to IT.next. And then I think you see the idea. Next time it'll see, okay, what value do I hold? In my random, I hold this value, and then in the dictionary, what does it map to? This node again. So it'll just create a pointer to itself. And then, yeah. So I think that should just work. And then we're returning new head at the end. All right. Well, that is it. So that took us about 30 minutes to solve, which is, to be honest, like if they ask you this at Google or something, I think I'm at home now and I'm doing this on my iPad, so it's way easier. But when you're nervous, and I think this was a Leetcode medium, so this usually this is the kind of questions they ask you. So I think, yeah, you should be fine in 30 minutes. In my experience, interviewers, they give you as much time as you need to solve these problems. All right, well, that's pretty much it. Until next time.